Hello friends, welcome back to our YouTube channel Maths and Electronics Tutorials. In today's video, we are going to learn about Introduction to Semiconductor Devices. This video is helpful for both intermediate as well as diploma students. So let's start our video. Let's start with the classification of solids. Solids are of two types, crystalline and amorphous. So, firstly, let's know about the crystalline solids. These have sharp melting points and are anisotropic. So, what is anisotropic? Anisotropic are those materials which show different properties in different directions. And sharp melting point. This means that when solid is completely melt within 1 degree Celsius range. Now let's know about the amorphous materials. Amorphous materials doesn't have the sharp melting point and they are isotropic. Isotropic means that these materials show same properties in all the directions. Some examples of crystalline solids are sodium chloride, germanium, silicon, etc. And some examples of amorphous solids are glass, polyvinyl chloride, etc. Now, let's know about the band theory of solids. The electric conduction in the solids is due to the presence of free electrons which are very loosely bound to the atom. So, in this figure you can see that this symbol represents the atom and this symbol represents the electrons here. So, to this we have applied an electric field or the voltage. So, now the free electrons are easily moved by an applied voltage. Next is an isolated atom has well defined energy levels. So, energy levels can also be known as electron shells or the orbits. This is the figure of an atomic structure. So, in center, this is nucleus and these are the electron shells or the orbits. So, now here you can see that these are the electrons. So, using the formula 2n square, we can find out that how many number of electrons can be placed in a single shell. So, let's take this shell as 1, 2, 3 or we can take it as K, L, M like that. So now we will put 1 in the place of n representing the first electron shell. So now it will be like 2 into 1 square. So that is 2 into 1 is 2. Hence we can replace 2 electrons in the first cell. Now if we put 2 in the place of n, then we can see that 2 into 2 square, that is 2 into 4, which is 8. So we can place 8 electrons in the next shell, that is L shell. This how we place the number of electrons in the remaining shells. So now energy on electron depends upon its orbit, principal quantum number. So here n represents the principal quantum number. Here you can see that in this formula 2n square, this n represents the principal quantum number. But solids are so closely spaced such that the energies of outer bit electrons are influenced by the neighboring atoms, and inside the crystal of each electron has a unique position and no two electrons see exactly same pattern of surrounding charges and each electron have different energy levels. Different energy levels are spread into bands called as energy bands. So now let's know some terms related to energy bands. First is valence band. Valence band specifies the energy level of electron present in the valence shell of an atomic structure. So let's take an example. We have taken an example of boron. Boron's atomic number is 5. So this is the atomic structure of the boron. In center there is nucleus and this is the first orbit and this is the second orbit. Since its atomic number is 5, so in first shell we can place 2 electrons and in next shell we place the remaining electrons, that is 5 minus 2, which is 3. So 3 electrons are placed here. Now we can see that the capacity of next shell is 8 according to the formula 2n square. Now we can see that there are still 5 electron spaces left here. So the boron will give away these electrons to any other element. Now the outermost orbital of the shell, that is this, is known as the valence shell, and electrons in the outermost shell that are not filled are known as valence electrons. Next is conduction band. Conduction band holds the electrons that are responsible for conduction. Next, what is Fermi level? It is occupied by an electron in valence band at nearly 0 kelvins. It is the highest energy level. And valence band and conduction band are the closest to the Fermi level. Next term is energy gap. It is represented as Eg. Difference between top of the valence band and bottom of the conduction band is known as energy gap. It is expressed in electron volts. Now, in this diagram you can see that this is conduction band and this is valence band. This is increasing energy and here this is Fermi energy. Now, you can see the small space between the conduction band and valence band. And this is the bottom of the conduction band and this is the top of the valence band. So, the difference between these two is known as the energy gap or the band gap or the forbidden energy gap. Now, let's know about the energy gap of conductors, semiconductors and insulators. So, the first diagram is of conductors. This is the conduction band and this is the valence band. So now the electrons flow from conduction band to the valence band for the conduction. Now there is a overlap. So this is the energy gap of the conductors. Here you can observe that there is no gap. In fact, there is a overlap. So the electrons can easily flow from the conduction band to the valence band. Hence, these are known as conductors because the current can pass very easily from conduction band to the valence band. Next is semiconductors. This is the conduction band and this is the valence band. There is very small gap between the conduction band and valence band. So, by giving the small voltage, you can pass the electrons from this band to this band. Hence, these are known as semiconductors. And there is small energy gap in the semiconductors. And the last diagram is of the insulators. This is the conduction band and this is the valence band. You can see that there is large gap between the conduction band and the valence band. Hence, electrons cannot flow from this end to this end. So, there is no conduction. Hence, these are known as insulators. Now, I hope that everyone understood the topics covered in today's video. Thanks for watching our videos. Please like, share and subscribe our videos and also let us know your comments through the comment section.